let's look at number 41. For the complex number I and an integer x, which of the following is a possible value of I to the x? So the important thing here is that they're looking for a value of I to the x. They're not looking for x, the exponent. They're looking for the value of I to the x. So let's see what we need to do here. Does everybody know what I equals? The complex number I is the square root of -1. If you try and come up with a number that multiplies by itself to equal -1, you will unfortunately not succeed. There's nothing on the real number line that when multiplied by itself is -1. If you take a negative number like -3, multiply it by itself, you're going to get a positive number. So that's why they created a whole new number for this square root of -1 and called it I for imaginary. And so we need to figure out if any of these can be represented by I to the x or the square root of -1 to the x for any integer x. So really, let's just choose some integers as test values and see what we get. Good place to start is 1. Let's see, I to the 1 is just going to be the square root of -1 to the 1, right? Which is just going to be the square root of -1. That's not one of our choices. So let's keep going. I squared equals the square root of -1 squared, which is going to be squared, which is just going to equal -1, right? Because the square root of something times the square root of something, that same something is going to equal that something. In this case, -1. Unfortunately, that's not one of our answers, so we're going to have to keep going. I cubed equals the square root of -1 cubed, which equals the square root of -1 times the square root of -1 times the square root of -1. We already saw that this value here equals -1, right? So we simplify this just to get negative the square root of -1, right? Otherwise known as, in other words, i.e. in other words, just equal to -I. I probably shouldn't have used i.e. since we're talking about i's, but oh well. Next thing is, and unfortunately -I, negative square root of 1, is not one of our answer choices. Let's keep going. I hope you're not discouraged yet, because the answer is coming. I to the fourth power, the square root of -1 to the fourth power, equals -1, square root of -1, square root of -1, square root of -1. We know that this equals -1 and this equals -1, right? From previous examples. So this goes to -1 and this goes to -1. And so if we multiply those two, we get +1, which is one of our answer choices, B. So that's really good. And also, this is just something fun, is if, let's just go back to I to the 5th power, just for fun. And that equals I to the 4th power times I to the 1st power, right? When you multiply two of the same things with exponents, you just add the exponents. 4 plus 1 is 5. And I to the 4th we just found is 1, so that equals 1 times I, which just equals I. And so that actually brings us back around to the beginning of this pattern, and we start over again. So I to the 6th will be the same as I squared, -1. I to the 7th, which will then be the same as I cubed, equals -I. And then I to the 8th is the same thing as I to the 4th, which is just 1. So i's, interestingly enough, imaginary numbers, repeat through the sequence of I, -1, -I, 1. And they just go around in a circle like that as your exponent increases, which is just something interesting to know and could possibly show up on the ACT. So if they ask you something like, what's the value of I to the 200th? And you're like, well, I don't understand how in the world I would do that. I can't do this up to 200. That would take forever. But what you can do is you can take that exponent, 200, and divide it by 4, right? And actually, let's do 201. 201. Okay. Now 201. Let's divide this out and see what we get. 20 divided by 4 is 5. We get 20. And you get 0, 1, and then 4 does not go into 1. It goes in there 0 times. 0 times 4 is 0, and we have 1 left over. So 50 with a remainder of 1, right? And that's why you probably shouldn't do this on the calculator, because you get a 0.25 rather than knowing that the remainder is 1. But the cool thing about this remainder 1 is you know then where it appears in this pattern. So we have the exponent I to the 1 right here, and this is I squared, I cubed, I to the 4th, right? Let's do the remainders of these exponents when you divide by 4. If you divide 4 by 4, it's just 1, right? And there's no remainder. 4 goes into 4 evenly, so your remainder is 0 here. If you divide 3, let's see, 3 by 4, 4 doesn't go into 3, so you just get a remainder 3. And same with 2. If you do 2 divided by 4, you get a remainder of 2, and same with 1, you get a remainder of 1. So whatever remainder you get when you divide by some large exponent corresponds to the value it equals. So in this case, I to the 201, our remainder is 1, so our value is I. So I to the 201, I'll rewrite it so it looks nice. I to the 201 is just I, which is kind of fun, but and helpful. So apart from that aside, let's get back to the last question in this set, number 42. A can of soda pop has the shape of a right circular cylinder with an inside height of 6 inches and an inside diameter of 2 inches. When you pour the soda pop from the full can into a cylindrical glass with an inside diameter of 3 inches, about how many inches high is the soda pop in the glass? Note the volume of a right circular cylinder is pi r squared h. They should always give you volumes and areas of odd shapes so that you don't have to memorize all of them. I still haven't memorized all of them, but let's see if we can do this one. Okay, a can of soda pop has the shape of a right circular cylinder. So I'm going to draw that. With an inside height of 6 inches, and an inside diameter of 2 inches. Now, when they say inside, I wouldn't get tripped up by that. They just are saying inside so that you know that the volume of the soda, of the liquid itself, is represented by this 6 inches and 2 inches. Just in case someone was thinking, was being nitpicky and said, well, you know, the diameter of the outside might be bigger than the diameter of the inside if this can has some thickness to it. And then the volume wouldn't necessarily be the volume of the liquid. But we're looking at inside, so you know that this will give you the amount of liquid. And so let's compute the volume of this so that we know how much liquid we're dealing with. V equals pi r squared h. An issue people might run into is considering this r, but they said it's diameter, it's the whole thing, so half of that is going to be r, so r is going to be 1, r equals 1, and height equals 6, right? So let's just plug and chug. Pi times 1 squared times 6 just equals 6 pi. So now we know how much soda we're dealing with, and now let's see what kind of can we're dealing with, or what glass we're dealing with. So we have the glass, also a circular cylinder, with an inside diameter of 3 inches. So that's all they give us. They don't give us the height. We assume that the soda pop will not run over the glass. It'll come to some point here, right, the soda, when you pour it in here, and we have to figure out what this height is. Let's call it h, right? And so we do know the volume and we know the diameter. Let's figure out what the radius is now. Radius is just half of that, r equals 1.5, right? And so we know the volume and the radius, so we should be able to find the height as well, using the volume equation. V equals pi r squared h. We know volume, 6 pi equals pi 1.5 squared times h. Let's look at 1.5 squared. Oh, sorry. 1.5 squared. Oh, 2.25. That's a nice number. So we get 6 pi equals pi 2.25 times h. We're solving for h, right? Let's divide by pi on both sides and just get rid of it. So now we have 6 equals 2.25h. Let's divide by 2.25 on both sides. Ooh, 6 divided by 2.25. 2.66666. Okay. 2.6 repeating equals h. And it looks like our answers are in fraction form. So this in fraction form would just be 2 2/3, right? 1/3 would be 0.3 repeating, 2/3 is 0.6 repeating, and so that's our h, which is what they're looking for. Let's see if it's one of our answer choices. It looks like it is 2 2/3. Perfect. Awesome. And I hope you enjoyed these videos and learned a lot from them. And thanks for watching.